This video is on solving equations and inequalities. Steps for solving multi-step equations. This is very similar to the video on SADMET, order of operations, where we are solving equations. The difference is that this is multi-step, so there's more than just two steps, where especially if we have variables on both sides of the equal sign. So the steps for solving multi-step equations. We're going to distribute if there are any parentheses. Distribute means to multiply to everything inside the parentheses. Then we're going to combine like terms if there are any on the same side of the equal sign. So on the left-hand side, we want to try and make it as small as possible. We're going to simplify the left-hand side. We will also try and simplify the right-hand side before we start solving. The third step, after we've simplified the left and simplified the right, we're going to cancel like terms if there are any on different sides of the equal sign. This is when we actually start solving and we add and subtract to both sides and we multiply and divide to both sides. When there's only one variable remaining, we use SADMET to get rid of the addition subtraction first and then multiplication division. There's one other note to get rid of multiplying fractions. Remember that dividing by fractions actually means to multiply the reciprocal. So if you want to get rid of multiplying fractions, in order to get rid of multiplication, you would divide. So we would have to divide the fraction. But instead of having a fraction, so we'd have a fraction on the top and then a fraction on the bottom, that just looks really complicated. So we can then, instead of dividing by fractions, we would multiply by the reciprocal. Just a quick example of that. If we end up having 1/2 divided by 3/5, this really means we're going to have the 1/2 times, because we're going to multiply, the reciprocal of 3/5. Reciprocal means to flip the fraction. So the reciprocal of 3/5 is 5/3. And then we would simplify that by multiplying fractions. If we multiply fractions, remember that multiplying fractions goes top to top and bottom to bottom. So we're going to do 1 times 5, which gives us 5 in the numerator, divided by 2 times 3 is 6 in the denominator. So when we see 1/2 divided by 3/5, we end up getting 5/6. And another way this might look, I'm just going to draw a little note over here. 1/2 divided by 3/5 could look like 1/2 over 3/5. This looks like a complex fraction is what it's called. It's when you have a fraction divided by a fraction. This can also be, another complex fraction could be 1/2 divided by 6. When you have a fraction already, and then you have a whole nother fraction bar, then you want to actually multiply by the reciprocal. So, looking at our first example, we're going to solve for x. So on the left-hand side, we want to simplify everything that we can. So on the left-hand side, we do have parentheses. Distribute if there are any parentheses. We are going to take, on the parentheses, we have this -2. So I'm going to make sure I take that sign with me. I'm going to distribute this -2 to everything inside the parentheses only. So I'm going to put it to that x and to that -3. Now on the right-hand side, so I'm not going to simplify it completely yet. I'm going to go ahead and look at the right-hand side. I have parentheses here as well. The negative sign, which is just a -1, is attached to that parentheses. So I'm going to make sure I distribute that to everything inside the parentheses. Nothing else. Only what's inside the parentheses. So on this problem, the 4x was not touched. I'm going to keep that 4x as it is. And I know that my equal sign will stay as it is. When I distributing, if there are any parentheses, gets rid of the parentheses. So I'm going to have -2 times x, which remember from a previous video, when you're multiplying, numbers and letters can multiply together. Numbers and letters cannot add together to make something smaller, but multiplication can. So negative 2 times x is negative 2x. And then negative 2 times negative 3, a negative times negative is a positive. 2 times 3 is 6. And then on the right-hand side, I'm going to have a negative times x, which gives us negative x. And then a negative 1 times a positive 7, which gives us a negative 7. I have no more parentheses, so now again I want to combine my like terms if possible. So on my left-hand side, I have a 4x and a 2x. I want to combine those, but I cannot combine it with a 6 because the 6 does not have an x. So I'm going to take this 4x minus 2x, and that will give us 2x, because 4x's minus 2x's is 2x. Everything else stays as it is, because nothing else can combine. So I keep my plus 6 equals, and now I have negative x minus 7. I cannot combine those because that is a letter and that is a number, and I cannot add them or subtract them any further, so it stays as negative x minus 7. So I've just done my second step. My third step is to cancel like terms if there are any on different sides of the equal sign. What I want to do is I want to get all of my x's on one side of the equal sign. I have a 2x and a negative x on different sides. So if I want to get them to the other side, I have to solve or undo or do the inverse operation. So if I wanted to move the 2x, I'd have to subtract 2 from negative 1. Well, that would mean I would just keep getting more negative. But if I wanted to move the negative x, I could add the x to the other side, and that would stay positive. So in fact, I want to add x to both sides. Now, because I'm adding it negative x plus x, that'll give us 0. I can only add my x's to my x's, so I can put plus x over here. Now, the reason I'm doing this is so that I can get all the x's on one side. That will end up giving us a 3x. And now we have no x's here, because those will cancel out. So I'll go ahead and say negative x plus x goes away. But I still have this plus 6. I know that I want to get everything, only the x's on one side. So I can go ahead and move that 6 to the other side, because I don't want it on the same side with my 3x. So in order to move that, I can subtract the 6, because I want to get it to the other side. So now I have negative 6 here, and I need to subtract 6 from both sides. I can only subtract numbers from numbers. Again, the reason we do this is because 6 minus 6 is 0, and that can go away. Now, negative 7 minus 6 is negative 13. But I need to make sure I keep bringing down my equal sign, because it is an equation. Now, in order to finish solving this, there's only one variable remaining. I only have one letter x in the entire equation now. I need to use SADMEP still to get rid of any addition, subtraction, or multiplication. This is 3 times x, so again, I'm going to do the inverse of multiplication, which is division. So I'm going to divide everything by the 3, not the x, because the x needs to stay. Do not touch that x now that we only have one of them. So I'm going to divide by 3 only on both sides, because the 3 divided by 3 gives us a 1. That is why we can do that. So our final answer, because x will be alone, is x equals negative 13 divided by 3. And that's how we write our answer. This is called an improper fraction. Improper fraction. We're going to keep it like this because we can actually do a lot more with fractions than we can decimals. The second example, I have, going back to here, distributed in parentheses. There are no parentheses in here. I'm going to combine like terms if there are any on the same side of the equals. So on my left-hand side, I'm going to simplify it as much as possible. I have a term, negative 2/5 x, and I have plus 4. These cannot combine together because the first one has an x and the second one doesn't. On the right-hand side, I just have 8. So there's no combining that I can do right now. So now I'm going to start solving by canceling like terms if there are any on different sides of the equal sign. So I'm basically just going to solve now. I'm going to use SADMEP. I want to add and subtract away first. So my x has a negative 2/5, which is multiplied, so I cannot focus on that yet, but it says plus 4. I can subtract the 4 from both sides because I want to get that x completely alone. I have not touched that negative 2/5 x equals, and now we have 8 minus 4 is 4. Now I need to get rid of the negative 2/5 times x. Well, this is when I have multiplying fractions. So negative 2/5 is multiplied, and it is a fraction. So in order to get rid of the negative 2/5, I multiply by the reciprocal. So I'm going to take the negative 2/5. I'm going to keep the sign with it. I'm going to multiply by negative. Flip the fraction of 2 over 5 is 5 over 2. But I have to multiply to both sides. So I'm going to multiply on this side by negative 5 over 2. The reason this works is because a negative times a negative gives us a positive. 5 on the top crosses out with 5 on the bottom because that becomes 1. And 2 on the top crosses out with 2 on the bottom because that becomes 1. And we're left with x. So we have x here, and then we have equals. Now, when we're multiplying a whole number times a fraction, this is the same thing as saying, instead of it being 4, I'm going to make a little note, 4 times negative 5 over 2. If I rewrote this as a fraction so that I can see it as top to top, bottom to bottom, well, the denominator of 4 would be 1, because it's 4 divided by 1 keeps it at 4. So instead of me multiplying 4 to the top and 4 to the bottom, I'm really multiplying only the 1 to the bottom. So that becomes 4 times negative 5 is negative 20 divided by 1 times 2 is 2. And then we simplify if we can. Negative 20 divided by 2 is negative 10. So x is equal to negative 10. And that is our solution. This is solving multi-step equations or solving equations with fractions that are multiplied to your variable.